Hello there, I'm Eric with Lucid Motors. You may have seen videos of a Lucid Air being charged at an Electrify America charging station recently. The Lucid Air Dream Range was able to add 300 miles of range in less than 22 minutes. It also set a benchmark exceeding 300 kilowatt of power during its initial charging phase. And today I'd like to take the opportunity to shed some light onto charging as a topic in general, our Lucid charging performance and how it works, as well as some of our hardware that we've developed in-house, the Wunderbox. All of that technology has achieved the remarkable fast charging speeds of the Lucid Air. Charging an electric vehicle, as you know, is essentially nothing else than the process of filling up the energy in the battery pack of the electric vehicle so that you can use it while driving or listening to music. Now, charging or the ability to charge an electric vehicle at your home or at your workplace is actually one of the core advantages of electric vehicles. It's very, very convenient. You never have to see a gas station ever again. Now, how do we charge the Lucid Air? Here you can see the charge port of the Lucid Air. From here, the power flows into the Wunderbox, which is the epicenter of our high voltage management system. Inside the Wunderbox, we manage all power flows to and from the battery. We manage the AC power, the alternating current power, from your home charger, for instance, that gets transformed into DC power that goes into the battery. We manage the DC power at fast charge stations in the Wunderbox. We have a boost charging conversion system inside the Wunderbox, which enables us to charge at heritage infrastructure at lower voltage levels, which then boosts the voltage up to 900 volts. We supply our thermal system with intermediate voltage at 400 volts. And last but not least, the Wunderbox is beautifully tied into our vehicle body structure, enhancing our crash performance as well as noise, vibration, and harshness performance. We really use the Wunderbox in many, many ways, and that's why it's called the Wunderbox. Now let's go back to that charge port that you will be interacting to charge your Lucid Air. This is the charge port. Up here we've got the AC, alternating current connection, and down here the DC, direct current. Now, in order to utilize the AC port, you will utilize, for instance, our Lucid mobile charging equipment. It comes in every Lucid Air. It's this little box. It can supply up to 9.6 kilowatt of power to the Lucid Air. Conveniently, it comes with two adapters, one for your 110 volt connector that allows up to 1 kilowatt of charging, and a NEMA 1450 connector that enables up to 9.6 kilowatts. Alternatively, you can also get our home wall box. This box on a 100 amp breaker delivers up to 19.2 kilowatt to the Lucid Air, and that's pretty fast. So you plug in your Lucid Air at home every single night, and every single morning you'll have the full range or the range you desire inside your battery pack and can take off. You can also charge, obviously, at your workplace or in any convenient parking situation at convenience stores or malls, etc. On the occasions that you want to take the Lucid Air on a much longer trip than the Lucid Air's already long range provides, you will be interacting with a CCS combo charger at, for instance, Electrify America charging stations or other fast charging stations. Here you will be using this CCS combo connector, plug it into the Lucid Air's charge port, and be able to charge at above 300 kilowatt at peak, achieving really fast charge times. In the independent charge test, the Lucid Air managed to add 100 miles in just 6 minutes, 200 miles in 12 minutes, 300 miles in under 22 minutes, and 416 miles in 37 minutes. By the way, 416 miles is greater than the full range of any other competing EV rated by the EPA. Let's talk about charging speed. Charging speed is not just about the kilowatts that we can draw from the grid and push into the car, but it's how quickly can we actually add range back into the car. And that range into the car and the power we can draw come together by using the vehicle's efficiency. And efficiency is one of the core tenets of Lucid. Charging adds energy to the battery pack of the car, so if we can double the efficiency of the consumption of that energy, we can double the range that the vehicle can drive with that given energy. The Lucid Air is a very, very efficient car. It's got a large battery pack, very energy dense. It's got very high vehicle efficiency. Our Grand Touring model achieves 516 miles of range out of 112 kilowatt hours, which gives it an efficiency of 4.6 miles per kilowatt hour, which is a very good efficiency. Now, in case you want to extend your range and visit friends in San Diego, let's say we leave San Francisco, drive all the way down to San Diego, our smart navigation planner will aid your trip planning and find a DC fast charger along the way. That minimizes the time that you will spend at that fast charging station. By the way, once you plug the vehicle in, the vehicle communicates with Electrify America's cloud and backend systems and enables plug and charge, which is a very convenient feature. It essentially recognizes that a Lucid Air has been plugged in. It validates that you have the charging plan from Lucid, connects the systems, and enables the charging of your vehicle. Once you're done, after 6 to 12 minutes, 100 or 200 miles added, you set off to San Diego, visiting your friend, ready for the party. On this trip, the Lucid Air's carbon footprint is less than 30 kilograms of carbon dioxide, and it costs you less than $30. A comparable luxury combustion engine vehicle would have produced roughly 180 kilograms of CO2 and cost you way over $100 at today's fuel prices. And by the way, given that the Lucid Air is electric and you have a solar system on your roof, if you had used that solar power to charge the Lucid Air, then you would have not generated any carbon emissions, which is really benefiting our planet. Since we did fast charge on this trip down to San Diego, we want to understand how we achieve this real fast charging performance. A core enabler is obviously because we design all our critical systems in-house. That is the battery system, the battery management system, the thermal system, our Wunderbox, and we know all the cells' specifications and capabilities really, really well. Now, the required voltage of a cell to reach a target current varies with the temperature. Also, the state of charge, so how full the cell is, matters, and the cell's history, how has it been treated over its lifetime. So we have a real tough balancing act between current voltages and temperatures that we have to navigate to keep the cells happy, achieve great charge times, and cell durability. Now, let's look at what happens inside the cell while we're charging. So I'm going to put onto the x-axis the state of charge, the SOC of the cell, starting at 0%, going to 100%. Onto the y-axis, I'm going to put the voltage of the cell, because a cell changes its voltage while being charged or at different states of charge. And the cells we are using have a voltage of 4.2 volts when they're fully charged and around 3.2 volts when they're at 0% charge. When we charge a cell really, really slow, then the voltage increases roughly linearly along this graph. And when we now want to fast charge a cell that is at 0% charge, we apply an external charging voltage that follows roughly this curve. And that results in a charging power that we need to pull from the grid that follows roughly this graph. This is the Lucid Air's charging curve on a cell level. And now you already know from Peter's tech talk around the battery pack that we've got 220 cells in series, making up our 924 volt boardnet architecture for the high voltage battery, which means on a pack level, out here we see 924 volts when the battery pack is completely full, and around 700 volts when the battery is at 0% state of charge. Now, on the secondary y-axis, I'm going to add the charging power, because you also know that when we charge the Lucid Air, we can achieve over 300 kilowatt of charging power, 300 kilowatts, and down here is 0 kilowatts. So this is a comprehensive picture of cell and pack in one picture. Now, I want to focus on charging power, the resulting voltage, and the current that we need to draw to achieve that charging power. So at peak power of around 300 kilowatts, we go down to our charging voltage curve, and here we find a value of around 840 volts. So in order to achieve 300 kilowatts, we apply 840 volts of charging voltage, which results in around 360 amperes as the charging current. And that's really important now. Why are those 360 amperes really important? I'm going to now introduce two high school physics formulas that you all remember, of course, into the conversation. So we all know that power equals voltage times current. And we also know that when charging, we create resistance losses inside the system that follow the formula of I squared times R. Now, since we've got a high voltage system and we charge at high powers, our current is fairly low, 360 amperes. If we look at common day electric vehicles, their high voltage architecture is typically around 400 volts. So roughly half than our voltage, which means their charging curve is also roughly half as high as ours in terms of voltage. If we now want to keep the charging power constant, but we halve the voltage, we need to double the current. That is this first formula. If we double the current and look at the losses outside of the pack, we see that we quadruple those losses. And that is why it's really important to keep charging current as low as possible. Now I'm going to look at the charging voltage curve of a 420 volt vehicle. And we can see it's going to follow very similarly the shape of ours, just at half the voltage. And already you can see graphically that at the peak power of 300 kilowatts, there's an enormous mountain we have to bridge by doubling the current in this case, which induces 4 times the resistance losses in the charging system. With that said, we're looking at about 720 amperes in order to achieve 300 kilowatts at 420 volts. Now here comes another fact, that the CCS charging system is current limited at 500 amps. And it is limited for a good reason, because we know that if we just increase the current in a system, we will incur losses, and a lot of them. So it's limited at 500 amps, which means now a vehicle at a 420 volt charging voltage times the 500 amps current limit can only charge at about 210 kilowatts. The Lucid Air is not affected by this charging power limit. All these charging curves and charging behaviors are managed by our in-house developed software. We develop battery algorithms, the battery management system, and all control algorithms in-house, and have therefore total control over over-the-air updatability, which means we can keep the Lucid Air improving over time as we gain more knowledge of charging our battery cells. Now that we understand charging, let's talk about the other components and functions inside this wondrous Wunderbox. So the silver thing here is our aluminum die-cast housing. It protects the power electronics inside mechanically. It protects us mechanically and electrically from the power electronics inside, and it keeps the power electronics cool. On the left side here, we've got all the high current connections. On the right-hand side, we've got all low current connections. This gray connector here manages all communications into the Wunderbox. And these two black inlets here don't actually supply any electrons. They are for cooling, for water glycol, and they help cooling our silicon carbide switching devices in this center portion of the Wunderbox. And we use silicon carbide to reduce the losses during charging. Now let's look inside the Wunderbox. Inside we have all kinds of electronic components and cables. First of all, we start with the power board with all the switching devices and magnetics. Then this here is the control board, the brains of the Wunderbox. This manages all the DC fast charging, the plug-and-charge communications, the AC 19.2 kilowatt bidirectional charging, as well as the 50 kilowatt boost charging behaviors. On the right side, we've got the medium voltage power supply, followed by the high voltage junction box, which contains contactors and fuses to direct all the power flow inside the box. The structural die-cast housing contributes, as I already said, to the Air's excellent chassis stiffness that improves ride and handling, as well as it reduces the NVH noise in the cabin and improves crash performance. On this side, we have our high voltage junction box with its many contactors, fuses, and bus bars. These contactors open and close to enable and disable various functions. This allows us to make the best use of the power electronics on board. The Wunderbox was laid out to minimize the distance between the high current connectors. Here we are looking at the Wunderbox from the other side, where the connectors connect into the Wunderbox. So we've got the highest currents being managed within a very small and contained area. This here is the charge port inlet. Here we connect to the external chargers. This connection goes to the high voltage battery, also managing real high powers. And here is the connection to our front drive unit. On top here, we've got the AC charge port inlet. And due to the lower voltage of your home charger, the current is actually fairly high at 80 amps, so it's good to have it really close by the other high voltage and high amperage connections. By minimizing the length of the conductors inside and outside the Wunderbox, we reduce the system resistance and therefore all the waste heat. This improves the efficiency and performance while reducing weight and cost. This arrangement reduces cable length inside the car and can help reduce assembly time. On this side of the Wunderbox, you will find high voltage connections to our 12-volt DC converter, that is this connector, the compressor, and the cabin heater. Directly inside, we have our 10 kilowatt medium voltage power supply. This in-house designed DC-DC power supply steps down the full pack voltage to generate a steady supply of 400 volts to our high voltage heater and the air conditioning refrigerant compressor. This unlocks the flexibility in our system architecture to improve performance and reduce cost. By integrating the medium voltage DC power supply, unlike other EV competitors, we were able to choose our powertrain voltage at 924 volts, designing for performance and better charging. At the center of our Wunderbox, we have our silicon carbide-based 19.2 kilowatt bidirectional AC to DC charger. Like all EVs, an onboard charger is needed to charge the DC battery from the 120 or 240 volts AC you would get from your home, a workplace, or other public AC charging stations. Our in-house developed two-stage design firstly rectifies the grid's alternating current, converting it into direct current. It also boosts this DC voltage to the value needed to charge the battery pack. A traditional approach to stage 1 uses diodes. Those are passive devices like one-way valves. And these passively rectify the AC to DC power. We instead chose active rectification through the use of additional silicon carbide switches. And that brings us 3 key benefits. Firstly, it is more efficient than the passive diodes and allows for power factor correction, yielding incredibly efficient AC charging of up to 95% efficiency. Secondly, we are able to operate in reverse, and this now turns the charger into an inverter to convert the battery DC into AC power. And that's exporting AC power that makes our charger bidirectional. And thirdly, by splitting into 2 stages, we can now reconfigure them into 2 parallel 25 kilowatt each DC boost chargers with a combined capacity of 50 kilowatt. This smart arrangement eliminates the need for a dedicated DC boost charger. High-power CCS charging stations today generally provide the above 900 volts that are required to charge the Lucid Air natively. At these stations, the Wunderbox directly connects the station and the battery pack. It's basically a pure pass-through. It doesn't convert anything. Some older stations, generally limited to 50 kilowatts, are not able to provide the full 924 volts that are required to charge Lucid Air's pack. The Air has backwards compatibility with these stations via Boost DC charging. Wunderbox's onboard charger takes full advantage of the highly efficient switching devices in our 2-stage bidirectional AC charger. I mentioned bidirectional charging many times, so now I'd like to talk about future applications for our customers. The ability to reverse power flow turns the Lucid Air into a mini AC power station that can deliver power from vehicle to anything, termed in the industry as V2X. One of these anythings is a vehicle, which makes it a V2V, enabled by this adapter. We plug this adapter into our Lucid mobile charging cable. And with this, the Lucid Air becomes a mobile charging station for other EVs. Let me demonstrate to you how this works. First of all, we're going to open up the charge port door on this Lucid Air here. This is going to be our donor vehicle, and we're going to do it from the glass cockpit. There are 2 ways of opening up the charge port door. So we're going to connect the mobile charging cable to the donor vehicle. And this vehicle is going to provide the power for the second vehicle that we're going to right now. And here we'll open up the charge port door by pressing it at the lower right corner. It opens. Now I'm going to plug in the charging cable into this card. The mobile charging connector is starting its communication with the vehicles and enabling the charging. The white light indicator is going to turn green, as it just did, to indicate that the vehicle is being charged. Also, the light blade in the front, or the tail lamp, will give us a light animation indicating that the vehicle is being charged. Another bidirectional charging application is vehicle to home, or V2H. This means that the Lucid Air will be able to feed energy back to your home in order to offset your home's power use. This application is enabled by the Lucid connected home charging station and some additional residential equipment to monitor the power flow. It can reduce your power bill and store solar energy during the day to be used at night. This V2H capability, combined with a way to disconnect your home from the grid, enables the Lucid Air to feed power to your home during a power outage. And now to our final application enabled by V2X, we have vehicle to business, or V2B. And here, along with providing the power to your home, the Lucid Air can add value to your workplace also. Just imagine several Lucid Airs plugged into a building. In this scenario, they could help reduce your business's power bill by offsetting power demand peaks or shifting the power use. Thank you everyone for watching our tech talk today about our charging innovations and our great Wunderbox technology. All our tech talk videos highlight our in-house technology. So stay tuned for the next one. Thank you.